Okay. This is lesson 7.3 on algebraic expressions. Before watching the recording, please make sure that you have a graph sheet of paper with you, a pencil, and perhaps a different colored pen and a highlighter. If you need to pause the recording to grab those items, please feel free to do so. Also, please allow yourself enough time to jot down today's date, as well as the lesson title, 7.3 Algebraic Expressions. Again, pause the recording if you need to do so right now, and I'm going to continue. Before we get into algebraic expressions, there are actually two vocabulary terms you need to be familiar with. So I'll jot these down and you can jot down the definitions with me. So the first definition we'll deal with is algebraic expression. Oops, and I just spelled it incorrectly. Here we go. So in the previous lesson, we dealt with writing down the pattern rule sort of in an informal way. Now we'll move on from there where we'll be writing down the pattern rule from a t-table in the form of an algebraic expression. So an algebraic expression can be defined as a phrase that uses operations with numbers, variables, or both. So again, an algebraic expression is a phrase that uses operations with numbers, variables, or both. Two examples of an algebraic expression could be, for example, x plus 100. Or you could have 90 minus x. Those would be two examples of algebraic expressions. Note that there's no equal sign. All you simply have is variables in each. You have an operation and you have numbers. So these two can be defined as algebraic expressions. I'm going to take my highlighter and highlight the definition here, and you can do the same on your page. Now I'm going to move on to the next definition. So please jot this down as well. The next definition we'll deal with is a variable. And variables you should be familiar with by now, but let's formally define variable. So variable is a letter that stands for an unknown number. So again, a variable is a letter that stands for an unknown number. And again, I'm going to take my highlighter and highlight this definition too, and please do the same on your page. The most common types of variables in math that you'll come across, and you probably know this, X and Y are probably the most common variables, but you can use any letter. And the preference is that you use cursive when you are writing down variables in algebraic expressions or in algebraic equations. Now that we have been introduced to the definition of algebraic expression and variable, let's move into some examples of algebraic expressions. Now, you'll be expected to be able to interpret algebraic expressions, meaning being able to tell what the meaning of an algebraic expression is, and you should be able to write an algebraic expression given a description. So let's start with algebraic expressions first. So let's do one example here. So first example, suppose you were given x plus 100. Okay, so x plus 100, again, is an example that I showed with you in the previous definition. If we were to interpret what x plus 100 means, we would break it down. We know that x stands for any unknown number, and you're adding 100 to it. So when you're writing down the definition, and I'm going to do this in a different color, and you can do the same on your page, I would say the definition would be you're adding 100. Essentially, you're adding 100 to x, but you're adding 100 to the number that x stands for. And that's the expectation in terms of how you interpret an algebraic expression. So again, x plus 100 means you add 100 to the number that x stands for. Okay, now I'd like you to try an example on your own. I'm going to jot down number 2, and I'd like you to pause the recording after I jot down the example and you try to interpret it yourself. So number 2 is a plus 50. So go ahead, pause the recording, and then when you're finished, play the recording so that you can check your answer with what I have. I'm going to continue. So in a different colored pen, I know that a is my variable or my unknown. So how I interpret this is that I'm adding 50 to the number, I'm adding 50 to the number that a stands for. Again, I'm adding 50 to the number that a stands for. Okay, example number 3 will deal with subtraction. So I'll work out the first example in this section with you, and then I'll give you an example that you should work out on your own. So number 3, let's go with 50 minus x. Now, when you're dealing with subtraction in an algebraic expression, the order matters more in terms of how you interpret it, okay? So we would say that, again, x stands for an unknown number, and that remains the same. Sorry, I'm just going to fix this here. But you're subtracting the number away from 50. So the way you interpret that would be the following, okay? So you would subtract, so again, jot this down, you would subtract the number x stands for from, and this is important, please make sure you're using from when you're subtracting, from 50. So I'll repeat, because x appears second in the algebraic expression, you're taking away whatever that unknown quantity is from 50. So you would say you're subtracting the number x stands for from 50, okay? Okay, now I'm going to give you another example involving subtraction, but it will be the reversed order. So I believe this is example number 4. So jot this down on your page. So number 4 will be x minus 50. Now, you may pause the recording now and try to figure out how you would interpret this one where you have x minus 50. How would you describe this algebraic expression in words? I'll give yourself a couple of minutes to figure this out, but I'm going to continue. And again, if you've written it out, please feel free to check your answer with what I have come up with. So with x minus 50, the variable appears first in this subtraction in this algebraic expression involving subtraction. So the way we interpret it this time is you're going to subtract 50 because it appears second from the number that x stands for. Notice the difference between this and the previous example where you had 50 minus x. In this case, 50 appears second, so you have to say you're subtracting 50 from whatever your unknown number is. Okay, on your own, for the next one, I'd like you to try it on your own and check your answer with me in a couple of minutes. So pause the recording, number 5 is 90 minus x. So figure out how you would interpret this algebraic expression. Be careful of the order when subtraction is involved. Okay, I'm going to continue. So if you're checking your answer, you would subtract, because this is similar to example number 3, you would subtract the number that x stands for from 90, because 90 appears first. And remember, don't forget the from 90. Okay, our next example will involve multiplication. Now, there's a certain type of notation you have to make sure you're following when you're dealing with algebraic expressions or when you're dealing with algebraic equations. Now, if I jot down here, and please write this down as well, 100n, and n is my variable here, whenever you have no space between a number and a variable, this operation automatically means multiply. We actually try to avoid in algebra using the multiplication symbol because that often can be mistaken for the variable x. So always assume when you have a number attached to a letter, you usually assume it's multiplication. So because I've already hinted that this means multiplication, when you interpret this, you would say multiply 100 by the number n stands for. Now, with multiplication, the order in which you interpret it doesn't matter. It's really with subtraction where you have to be careful in terms of interpreting the order. So you could also say multiply the number that n stands for by 100. So multiply 100 by the number that n stands for. Okay. Now, the final two examples will deal with algebraic expressions that are two-step, which is in line with the types of patterns from the t-tables that you'll be dealing with this year. So this will be number 7, and it'll be a combination of two operations. And again, you just have to figure out and interpret what it means. So say if we put together 100n plus 50, think to yourself what that means. If you want to pause the recording, figure it out yourself, and then double check with what I've come up with, please feel free to do so. Then I'm going to continue here. We know that 100n, we can actually take it from an example number 6, means multiply 100 by the number that n stands for, and because we have to account for the second operation, and add, looking here, and add 50. Now, our final example will deal with another two-step operation. I encourage you to try to figure out yourself before I go over it in the video. So I can't remember what number this is. We'll call this number 8. If it's number 9, you can correct it on your page. Let's go with 45y. Actually, I'll make that closer together. 45y minus 75. So go ahead and pause the recording, figure out what it means, write down your interpretation, and then you can check with me afterwards. I'm going to continue here. So the way you would interpret that is multiply the number y stands for by 45